Okay, so today we're going to just kind of walk through an introductory of solving equations. If we want to solve an equation, typically we'll see an equation, it'll be of the form something like 2x plus 15 equals 7. Something like this. If we want to solve this equation, what we're talking about doing is finding a value, but finding all values for this x. So, if we were to solve this equation, we would end up with knowing what value x has. With that being said, and before we get into actually solving these equations, just one other term that I think is important, and that is equivalent equations. So, what are equivalent equations? Equivalent equations are equations that have the same values for their variables. So what that means is if I have two equations that are equivalent, the variables or unknowns in those equations will have the same value. What this means is that if I solve one of those equations, I'll know what my variables are for both of them, or for any of them. And so what this lets us do is it lets us make equations more useful, easier to look at, and easier to find what our x value is or what our unknown is. So, for example, if I have an equation, let's say 2x equals 1 plus 3. This is a fairly straightforward equation to solve. What we would do is we would say that that is an equivalent equation with 2x equals 4. And then, through some of the stuff we'll be talking about shortly, we would say that this is an equivalent equation to just x equals 4 over 2, so 2. So, since this is an equivalent equation with this, and this is an equivalent equation with this, these are all equivalent equations, and we know that in this equation it's very clear that x is 2, that tells us that x is 2 for this, and x is 2 for this. So that's how we use equivalent equations to solve equations. Basically, if we can get a equivalent equation where the value of x is the equation, it's given, then we know the value of x for every single one of the equivalent equations. Okay, so let's use that to solve a simple equation. So let's consider the equation. Let's see. 1 second. So let's consider the equation x minus 15 equals 3. So how do we end up solving for x? Now, this brings up an important property of equations and equivalence. It's the additive property of equivalence. And all that says is that if I add something to one side of the equation and I add something to the other, then the equation at the start and the equation that results will be equivalent equations. That is to say that if I add 15 to this side and 15 to this side, what I'm left with, which would be x minus 15 plus 15, so 0, equals, put a 15 there, 3 plus 15, which is 18. So that is to say, the additive property of equivalence tells us that when I take this equation and I add 15 to both sides, this result will be an equation that is the same as this, or is an equivalent equation to the one that we started with. So these are equivalent equations, and this equation, x is 18, and that means that for this equation, x is also 18. Okay, so the additive property of equivalence is one that we can use to solve all types of equations. Typically, they'll be of the form with a variable subtracted by something. So 10 equals, let's say, 5. So here we would invoke the additive property of equivalence, add 10 to both sides, Oop, don't carry that equals sign. So we would get x equals 15. X is 15 here. This equation and this equation are equivalent equations. That means x is here for this equation. We have solved this equation because we now know that x equals 15. Okay, so it seems pretty clear that if there is a additive property for equivalence, there is very much likely going to be a subtractive property of equivalence. So let's think through this. So if I have an equation, say h plus 7 equals 2. Now let's pretend we don't know about the subtractive property of equivalence. Before we even get into describing what it is, we know how to solve this equation, because we can always add any number to both sides of our equation in order to produce a equivalent equation. So let's do that. Here we would add, so we want the number here plus whatever the number we put here to be 0, so we would be adding negative 7 plus negative 7. And so what that would give us is h, 7 plus negative 7 is 0, equals 2 plus negative 7, which is the same as 2 minus 7, which would just be negative 5. So we really have the subtractive property of equivalence from the additive property of equivalence. So the subtractive property of equivalence is really just the additive property kind of in disguise. And really the subtractive property, if we examine something like j plus 13 equals 7, it's kind of a quicker way of writing, and maybe a bit simpler way of thinking about how we would do this. So instead of adding negative 13, we would just invoke the subtractive property of equivalence, and we would subtract. And all the subtractive property of equivalence says is that you can subtract the same number from both sides of the equation, and you'll get an equivalent equation as a resultant. So j 13 minus 13, 0, equals 7 minus 13, negative 6. Okay, so that's the additive and subtractive property of equivalence, and really you only need to have the additive property. That's the one that kind of lets the subtractive property flows from it. So, well, I think it's important to remember both of them. As long as you can get from the additive property to the subtractive property, I think that's really all you need. So, with that being said, what are some other properties of equivalence? Okay. Let's see. So, what about if I have x divided by 4, or x over 4, equals 3. If I were to solve this, I would need to invoke something called the multiplicative property of equivalence, which is kind of similar to the additive property, but instead of just adding to both sides, we are multiplying both sides by the same number. So 4 times x over 4 equals 3 times 4. So the 4's will cancel out, and I'll be left with an equivalent equation of x equals 12. So the big thing with the multiplicative property of equivalence is that we can multiply both sides of an equation by the same number, and the resultant equation will be equivalent. So here we have solved and found what x is, it's 12, and that means our original equation, x over 4 equals 3, we know what the value of x is in this. That would just be x equals 12. So we have solved this equation. Okay, so without doing much practice with this, let's really quick see if we can get the other important one, and then we'll go back through and do a little bit of practice with these. So what is the last kind of important property of equivalence that we'll be using to solve these equations? And it's going to be, well, let's just look at one first. If I were to solve this equation, what would I need to do? Well, I would need to divide both sides of this equation by 3. And luckily, I think they call it the division property of equivalence. Yes, wanted to make sure I'm using the exact right term. So division property of equivalence says that I can divide both sides of my equation by the same number, and the resultant equation will be equivalent to the original. That is to say that in this case, these equations, if you ignore the divide by 3, these equations are equivalent equations. And so that means we've solved our original equation, and we get x equals 2/3. So, let's think about this. Really, much like our subtractive property of equivalence, our division property of equivalence is kind of the multiplicative property under disguise. So if I have something like x times 5 equals 1, if I were to want to take this and get rid of this 5 here, I don't really need to use the division property of equivalence. I'm free with just using the multiplicative property, because I can multiply both sides of this equation by 1/5, and then by the multiplicative property of equivalence, I get, these cancel, x equals 1/5 is an equivalent equation to my original. And so that means for my original equation, which was 5x equals 1, I know that x equals 1/5. And so again, this is kind of to say that my multiplicative property of equivalence really gets me my division property of equivalence. And so really, as long as you just have your additive and your multiplicative down, as far as like, writing through and getting kind of a rigorous understanding of how we are able to get to this, those are the only two that you really need to be able to solve these. Granted, it's helpful to have the other two, just because multiplying by 1/5, it's a lot easier to just divide both sides by 5. These cancel. X equals 1/5. That's made a little mistake. That would be 1/5. My bad. So that's kind of a way of not having to memorize all of them, but it's still kind of useful to know all of them. And really, a lot of times the difficulty in solving problems related to this section and these subjects are going to be finding out which one you want to use. So, if we have some equations, let's say 3h equals 7, g plus 2 equals 6, z minus 5 equals 4, and L divided by 5 equals 2. So, I think it's helpful to take a look at some, group of equations, and first, before you even get to solving them, decide which property of equivalence are you going to use. Here, I do think it's helpful to know how to differentiate between the division and multiplication properties. But really, if I were to ask you on a test, or if you were to be asked on a test how to solve one of these, and you were to give the one that works but takes a little bit more thinking, that would be fine. So for this one, the one that, the thing that should jump out at you at which property of equivalence should I use to solve for h would probably be the division property, because we just simply divide both sides by 3. 3's cancel, and I get h equals 7/3. And I can simplify this, turn it to a mixed number, and that would just be 2 1/3. So that was kind of the more straightforward way of solving this. But if we wanted to, instead of dividing both sides by 3, we could have multiplied both sides by 1/3. So not worrying about that. And we'd have this would cancel with this. H equals 7 times 1/3, which would give us the same thing. So really, both work. It's just kind of pick the approach that you would like to use and stick with it. Is kind of the important thing with these. So let's go on. For this one, how would we go about solving g plus 2 equals 6? So there's a number of ways that we can look at this. And really, I think the most straightforward is the use of the subtractive property of equivalence. We subtract 2 from both sides, and we get g 2 minus 0 equals 6 minus 2 is 4. So g equals 4. So we've solved this one using the subtractive property of equivalence, and we get g equals 4. For this one, it looks like the most straightforward approach. We'll just be using the additive property of equivalence. We add 5 to both sides. And we get z minus 5 plus 5, just be z, equals 4 plus 5, 9. So z equals 9. These are equivalent equations, so we know for the original, z is also equal to 9. We have solved our equation. Now finally, we have this equation. And there's 2 different ways to do it. For the division approach, when it's, if we were to want to use the division property of equivalence here, it would be a little bit more involved. We would divide both sides by 1/5. And how we would get to the answer is L over 5 divided by 1 over 5 equals 2 divided by 1 over 5. And simply when we divide fractions, we multiply by the reciprocal. The 5's cancel, and we're left with L equals 10. But it's a lot easier to just use the multiplicative property, multiply both sides by 5, these cancel, and we get L equals 10. But both work, both get us to the same answer, so that's really just to say that if you make a mistake and you choose the one that's not quite the easiest, you're not going to get the wrong answer as long as the math is right. If your math is right, you can make kind of the wrong choice. As long as your math is right all throughout, you'll be fine. Okay, so that is how kind of an introduction to solving equations with a focus on one-step equations. So hopefully that helped. Let me know if you have any questions. Thank you.